We have Ms. Stephanie Sharo Chiesi. Ms. Chiesi is a former senior principal systems engineer at Raytheon Missiles and Defense. In 2017, she became the first Raytheon SERC Doctoral Fellow, beginning her studies at Stevens Institute of Technology in the School of Systems and Enterprises. Ms. Chiesi is also an inventor with 5 awarded patents through her work at Paragon and Raytheon. In 2020, Ms. Chiesi joined Science Applications International Corporation as a chief systems engineer, working with the strategy-focused team for digital engineering solutions. Ms. Chiesi will be presenting her talk, The Implementor's Dilemma for Digital Engineering. With that, I'll turn it over to you, Stephanie.
All right, thank you. Thank you, everybody. It's good to virtually see you in the networking sessions, and I guess get a chance to see me now. So let's jump in. Today, what I'm going to actually be presenting is a little different than the path that I have presented at previous SDSFs on my research. And this is another facet of it that I think is important moving forward in the research area I'm looking at for digital engineering implementation. So the digital engineering transformation that so much of the research that is sponsored by SERC deals with is definitely focused and a result of the digital engineering strategy that was published by the Department of Defense. This is looking at how do we implement digital engineering technologies in our engineering development process so that we can change our engineering decision making as a means for reducing the cycle time for bringing new capabilities and innovations to the warfighter. This is very much needed in order to maintain a battle space advantage to our adversaries, and also to improve the robustness and performance of those solutions that we have in the space. I feel like the slide that you're seeing now is something that will be in pretty much every presentation I make until the next digital engineering strategy might be released, just because it is such a focus and facet of how we are trying to transform our discipline. Something that I think is key about this is it's not just transforming the way in which we do engineering, it's the way in which we do all of the facets of our job. We're not looking at just changing or introducing a new mathematical formula or a new means of analysis. We're looking at changing how we collaborate, how we interact with each other, what data we see and what our access is to that, the periodicity. All of these facets really contribute to understanding what decisions we are making as we proceed in development, and how that influences the performance of these solutions that we are trying to then field. So at the heart of this part of digital transformation is the culture. It is goal number 5 in the digital engineering strategy. Even when we look at our own SERC research roadmaps, it is down here in our DE workforce and culture, goal 5. The challenge here is it's the challenge of changing how we do business. We're trying to overcome the language of practice. How is it that we've always done our engineering disciplines, and how is it that we need to do it in this digital engineering environment? How does it change where we're making our decisions, what decisions we're making, what data we're using to make those decisions, and who we are making responsible for those? Perhaps the other large contributing factor here is that this is a transformation that certainly we see in the system engineering community as one that we're trying to make to get away from document or paper-based products into the rest of the calculable environment, the data-driven environment. But it's a transformation that's not just within systems engineering. This is something that impacts our cross-product teams. It largely impacts our program management and business development organizations that have significant decision-making authority at our different industry companies. It affects the matrix organizations of those companies, as well as of the different customers and suppliers. It also, of course, largely affects information technology divisions. What kind of support is needed either on those teams, co-location, not co-location, And this is transformation that was needed before there was a COVID, before there was even an increase in remote learning, and remote participation and collaboration. Certainly there's been some changes there forced on it. I won't go into those, but the changes that we've had to make in all of our work and learning environments, being socially distant and being in our separate participating ones, is actually a part of this transformation we were already realizing. So the challenge that I see, and this is as somebody who's not just an academic doctoral student, but somebody who's been working as a system engineer for quite some time with a variety of companies as well, is that how do we actually make this real? How do we implement it? How do we get this out of just our research and small projects and go ahead and actually have digital engineering working in industry, in the different suppliers and contractors for the Department of Defense, such that we are realizing those desired results: shorter cycle time, more robust, and still high or higher performance or new capabilities that we want the warfighter to have. So the suggestion that I'm going to talk through today is look at approaching digital engineering implementation as a disruptive innovation to the way we do engineering. This is actually harnessing the Christensen book, The Innovator's Dilemma, where he presented 5 principles of organization for successful disruption for innovation, innovative products that took over markets or created markets that weren't known to exist, and in some cases drove other companies or products out of existence. Those principles are resource dependence. It's that small markets don't solve growth needs for large companies. It's the unknowable field of the market of disruption, the impact of disruption. It's knowing what capabilities a company has and what values that could be disabilities when you're trying to disrupt or confronted with disruption. And then it's looking at the attributes that make those disruptive technologies unattractive in established markets, but actually add value to emerging markets. So I'm going to look at how we approach this for digital engineering and take it one principle at a time. So first principle, resource dependence. This is getting at how do we ensure that the implementation we're trying to do with digital engineering has what it needs in order to really be evaluated for success and for further implementation. So the suggestion I have here is look to embed the projects that are going to develop and apply this DE where it's needed most. This is a matter of identifying the right group that's willing to take on this new technology, that is not going to look at this as a burden or as a different type of roadblock or barrier to what they are trying to achieve on their program. And the other key factor here is they need to be separated from the processes and metrics of these other projects. They're trying to do something with digital engineering and implement it in a different approach. And so it's going to be necessary to make sure that group is not held to the same metrics and standards as somebody who's following a company's, whatever their integrated standard process may be. It might be developed to be compliant for ISO or CMMI, whatever that culture is there. The metrics and measurements might be a hindrance to the resources that are needed for this team. So a couple of examples of how that need for separating the resources, separating out how a team is evaluated and allowed to proceed and grow within this new implementation, this digital engineering environment, is looking at the retail disruption patterns. So over time, as we evolved from having a department store focus to variety stores to discount stores, and then most recently to e-commerce, we can see successes and failures of some of the different companies that traversed those paths. When you look at a company back dealing with the change from the variety store to the discount store, there was a success there from Kresge and Kmart brands that understood that going from the variety store to a discount store, they were changing the way in which they were turning over their inventory. They were changing what the profit margin would be for success. And they split their different divisions, and the resources they allocated to both were held to separate metrics in order to achieve that success. And as a result, they were successful. Conversely, Woolworth and Woolco, in trying the same disruption, they were trying to also have both a variety and discount retailers under that same overall company. They didn't allow that resource independence there. They kept the discount chain held to the same metrics as the variety chain, and they were unable to meet that demand. They were not throwing the resources at it that it needed, and they were still measuring it based on the old matter. And they were not successful at actually getting that implementation in place, at having successful both variety and discount stores. So this I see as one area for digital engineering implementation, to look at how it is that we get people doing this in the workforce. Ensure that they are not being held to the same metrics as the programs that are doing things the way we currently do, or the way that company currently does, and make sure that they're not clamoring for the same resources to do that. Principle 2, this is looking at the fact that small markets don't solve the growth needs of large companies. So the challenge here for digital engineering implementation is placing projects that are going to develop and apply this digital engineering in groups that are small enough that they will get excited about small wins and opportunities. If your heart is set on winning a multi-billion-dollar contract, and you're going to do that right off the bat with digital engineering while you're also trying to combat that, and the team gets a win that is only a couple million, that team's going to see it as a failure, versus a team that is now submitting a proposal for something in perhaps a market they don't currently even have a foothold in, will be ecstatic over having even the smallest of contract awards, that they can also show progress and attribute to how they've implemented and how they've evolved the way they work in digital engineering. So again, there's this willingness of the group to do things differently, to not face a roadblock and immediately say, let's go back, and to not have that revert button, to just do it on paper, just do it in some other format. It's also important for showing that relative improvement or return for growth. And it's also a means of incrementally increasing that scope or project scale. It might be that it's just two different divisions at a company that are collaborating in a different way using digital engineering that enables them to more quickly respond to a small request for proposal that they otherwise would have no bid or would not have considered. And that could be a win that starts getting people excited, enthusiastic, and wanting to try this other approach to see, what else can I do? How else can that change the way in which I work, such that I can get a bigger win and then a bigger win? What I look at for comparison in the product space here is the mini mill industry and mini mill produced steel. This was a takeover of the markets from the integrated steel makers. The integrated steel makers had no problem giving up rebar markets. For them, it was something that had a product that did not need a significant quality improvement and did not have to, and it wasn't a huge volume or a huge margin of income for them. So they were more than happy to then focus on their higher quality products, their more profitable contracts, and mini mills took over that market. Well, next thing is that mini mills had enough of a margin there that they were able to invest in themselves and their own research and improve their quality so that they could then be competitive and offer a lower price point for angle iron and bars and rods. And that took over yet another market from these integrated steel makers. Well, bit by bit, the way in which the mini mills were able to reinvest in their own quality, improve their quality with the processes they had, which enabled lower price points and shorter turn time, they were suddenly competitive in those high dollar value contracts that the integrated steel makers so valued. And yet the integrated steel makers had not changed any part of their approach and could not compete with them in the same price point. So this
approach becomes a means of improving quality, perhaps in a different mindset than we think about with having to use IRAD funds. So implementing digital engineering in these types of projects that could be small market grabs could really grow and influence those larger market, larger contract ones. Principle 3, the market impact of disruption is unknowable in advance. I think the key aspect here for digital engineering is not to go in expecting it to work immediately as any of us think it has to function, as any of us are doing on our different pilot projects in research teams, etc. As a practicing engineer, and as many of you have or are practicing engineers, we are creative and we find ways to break things or change things from however anybody thinks it's been designed to work. That is our talent. That is our art. For digital engineering implementation, we need to plan to fail early and inexpensively. We don't want to fail early expensively because we're going to work ourselves right out of getting opportunities. But plan that we are not going to be successful early on, that we're going to have a lot of iterations, a lot of changes and flexibility in our teams, in what our digital engineering environment looks like, in what data we're connecting, in what decisions we're making, as we are trying to find out how we implement it in our different organizations. This, for the market impact and being unknowable, it's a matter of identifying a group that's willing to take on the new technology again. So where is it within our different companies that we have a group that otherwise is just not having what they need and is willing to do something different and perhaps fail and try again at it because there is no other alternative? Adopting that trial, learn, try again approach to feel out that market is the approach that I would recommend, that I think we should take for this implementation, because that's the way to get it encouraged and grow. It's taking on some of what we often call a grassroots approach, but trying to do that with the buy-in, not just of that certain grassroots group, but of a smaller community that really can then grow and blossom versus just being picked up and put on another difficult project. If all you do is pick it up and put it on some other project, you've just now doomed the first project that no longer has any of that expertise or desire or grow, and now this other project might have it. What we need to look at is how is that actually disseminated in growth? What is it that takes the transformation part of it to growth? And differently than, say, mentoring and that kind of on-the-job experience training. We're trying to get on-the-job training in there, of course, but part of what we need to look at is how does that then last? How does it last and how does it follow? And we might not know what those projects are now that we need to do that in. So trying to disrupt and trying to get into different markets and trying to, markets within our companies, I mean, and try, learn, try again, could actually open up spaces that we didn't realize for that growth. I think a good example here is actually looking at Honda in the late 60s. Honda leads came over to the United States to enter the motorcycle market, but just found that their product could not compete with the already existing players here. But it just took a few of them taking their bikes out in the hills in Los Angeles County on weekends and having so many people stop them and say, where can I get that? I want to go, I want to do this dirt biking thing. This is exactly what we need. They developed an entire market that nobody knew existed. It was completely unknown at the time. I think what digital engineering is maybe we need to tackle some of these different areas that may not be unknown, that are smaller questions than looking at just what is the entire history of my program and how the requirements have evolved and how the change has propagated. Maybe there are better specific questions we can answer with some of our same technologies that can emerge the market that we need to address in terms of getting this implemented and then getting bigger and bigger steps to implementing the rest of our research that we have here in this data-rich environment. I think this is where looking at the example of the Hewlett-Packard Kitty Hawk drive could tell us about the consequence. If we focus on just a technology that we're going to enhance and make sure it is the best possible, we may end up pricing ourselves out of the market where we really need to be. Maybe more of what we actually need to do would be valuable to supply chain or program management, not necessarily our specific engineering and our engineering areas in digital engineering. This team had anticipated the personal assistant market and knew what they would need for that hard drive, but the market there did not emerge as fast as their product had, and their product was so oversized and overperformed and overpriced for an emergent market that did want that in small handheld video game industry. So at some point we need to make sure that we are not over designing our digital engineering environments and that digital engineering implementation such that we can't actually go do it, or we don't have it in chunks small enough for us to do in the industries and in the companies that we are working. Principle 4, understand what a company's processes and values are that could be disabilities when we're actually trying to disrupt. Here, what we need to focus on is utilizing the resources that we have of the organization, which takes us back to Principle 1. We want to use those resources to address digital engineering implementation, but the processes and values often are going to be roadblocks or hindrances in that implementation. We know digital engineering is changing the way we work. Look at how we've changed the way that we work just over the last 6 months. It changes who we work with, what we deliver. It's sometimes changing who makes a decision or what data that person needs or understands to make that decision. What expertise do we need involved in the data generation or decision making? And that means the processes have to change in order to see that value. That shift of decision making and what that perceived value is, or understanding the value of the data presented, will be different. So those measures of value could change as well. What we consider performance or cost or schedule very much could change. So looking at how we are actually valuing and what changes in the processes need to be made needs to be recognized. We can't just do checkmark gates for checking the boxes in our standard process. We need to be willing to change those, because otherwise checking the box and saying, well, I just need this to check that box, we're getting back to that idea of now we're reverting away from this, doing this the old way. Now we're asking maybe for double work. We're not able to always do everything exactly that old way from a new way. That's one of those red flags that we're not being disruptive in the way we need to be successful.
5 minutes, Stephanie.
Perfect. Thank you, Kara. Principle 5. This is the principle that says attributes that make disruptive technologies unattractive in established markets are what could add the greatest value in emerging markets. Here, what I want to look at is, what do we have of digital engineering that is working at companies that are successful with complex systems, but perhaps they're not implementing digital engineering the way current research or some of our efforts are trying to grow it. If we look at the technology S-curves, for example, for the AI for SE and SE for AI, we have the research roadmap in the lower left that looks at the traditional technology S-curve growth we have of digital engineering, the technology development, and then the mission engineering focus. But what if companies that are successful with complex systems have a different way that they are either doing systems engineering or digital engineering that has changed that curve? They're working in on the lower right. If you look at we're working towards thinking this is application market A, but maybe they're in application market B, and they're finding a way to bring that into application market A. They could be ahead of where our technology development curve is. So this is looking at companies that could be doing complex systems within the same area as us, looking at SpaceX, that's another aerospace and some defense work company. Firefly is another aerospace engine type company. Blue Origin is out there and competitive with the other main Department of Defense contractors, both for NASA and DoD. But what they're doing isn't something, we're not seeing those participants at presenting at SERC. We're not seeing them presenting at a lot of our different other research-oriented avenues like NDIA or IEEE or AIAA and COSI, any of those. We're not seeing those names. So what is it that they're doing that maybe we don't know about, that we need to be aware of and bring in and look at? Maybe that's the way in which we need to take digital engineering. Another option is also maybe we need to look at that the application market B is something completely different. Maybe it's something like AWS, where that was developed by Amazon to handle their own issues with their delivery and their category system, but perhaps we actually could use, they've certainly grown that into a very different market space in terms of the users that you have for it. Maybe there are other markets that we need to look at in what digital engineering they're doing and implementing. And that actually should be something that we utilize to see success in changing our system engineering approaches and changing our culture. So in conclusion, so that I can give some time for comments or questions, I think the part that's not controversial among this group is that digital engineering is a cultural transformation. So the way that I'm suggesting that we might need to better or otherwise look at this transformation is to treat digital engineering as a disruptive innovation. We have 5 principles that have been discussed and are published for disruptive technologies that we could harness to be successful. And if we can align our research to harnessing those principles, that might provide something that could be a very big help to the culture part of that transformation that we need for actually implementing this, doing this. I think the challenge here is that obviously it's a very product-centric view in the innovator's dilemma to what we're trying to take to a process and design system for the implementer's dilemma. But I still think that there's a lot that we can learn there and a lot that we should be willing to look into in making this transformation. I did want to make sure that I give a special thank you to my dissertation advisory committee chair and advisor, Dr. Paul Grogan at Stevens. It's been a challenging year for so many and so most. And so for him, as well as the rest of the Code Lab team, they've been super supportive of all the changes that I know we've all seen and that I've seen as well in this research. But questions? I'll go back to my conclusion slide for that.
Thank you so much, Stephanie. There are no questions. Oh, one just came in right now from Wilson. How do you see the 5 principles of disruption overlapping with cultural change? Do you see similarities with other transformations like agile, product lines, etc.?
Hi, Beth. And yes, I think that agile product lines, those are good examples of cultural change that we are also addressing. I think this fits, I think digital engineering transformation fits right in with those. And if we saw that absolutely everybody was doing agile or everybody was doing product line, then we'd probably have a different methodology for that implementation that we'd be very willing to accept and mimic or research and adopt. But I think that we're not necessarily seeing that everybody has an agile adoption or a product line adoption. There are still some challenges there. So I think that the principles of disruption in terms of the overlap with cultural change, I think they actually characterize the cultural change. So I don't know if overlap is the term I would apply. I would say I think that they are meant to create a different dialogue about the cultural change so that we can come at it from perhaps a different perspective to be successful.
Thanks, Stephanie. And we have time for one more question. Tom McDermott asks, is the goal of the research to create a decision model that helps leadership do the right things?
Thank you, Tom. That is part of it. So in the research that I've been starting and proceeding with for my doctorate, I've been looking at, we have this digital engineering environment, and we have both humans, we have machines, and the things that connecting them right now are data, and the data flows, what data is available. We certainly understand some of the background of what's programmed into the machines and the way they will think. We know a little bit less about that for the humans, although we have what the humans tell us of how they think. But we're trying to find out, what is it that we need to connect, in what way and how fast, for digital engineering to actually improve cycle time, speed to market. So as part of my research, I've been looking at how do we get a surrogate model together to model that decision-making environment, the digital engineering environment. And part of that surrogate is defining agents that are representing decision makers. So the goal of this aspect is implementing some of those decision makers that I'm trying to code into these agents for being able to get statistically relevant data for analysis.
Thanks so much, Stephanie.